Now let's take a look at a greatest integer, or what we call step function. This is an interesting type of a function, and it's brand new as to almost everyone at this level. So let's talk about what would happen in this. I am going to do an XY table, and I am going to take just a small part of it to analyze. So I'm going to take just this part here, okay, so from 0 down to 2. I'm going to use these x values, 0, 0.5, 0.8, 1, 1.4, 1.5, and 2. So I'm going to determine right now what happens when I use that. So here I have the brackets for 0. And what that tells you for the greatest integer function, the brackets tell you that for the number that's inside here, you're going to use the integer that was last before it, unless it's an integer by itself. It is an integer by itself, so we'll use 0. And for the next one now, it's 0.5. So at 0.5, that's about here, and the integer then that is closest to that, that's the last one that's gone to. Remember, we're going in this direction. You always go from left to right, finding domain, finding other things like that. So what we do now is we say, well, the integer before that is here at 0. So that means that if the x is 0.5, the y value is 0. In the same way now, if 0.8 is here, and the integer that is closest before that is the integer of 0. And then now we have 1. 1 is itself an integer, so we don't have to go back to the integer before it. So we'll do that one. So now what I have here, in fact, yeah, let's do the next couple. If I put 1.4 in here, the integer that's last before it is the integer 1. 1.5, the last integer is 1. For a 2, the last integer is itself, 2. So what I have here on the graph is that I'm at 0. Every point along here is also at the 0 line until I get to the number 1. The number 1 ends that line, but to actually fill it in, I have to go up to above it, and that's this point right here. And that one continues. Everything in between it and 2 reverts back to 1 for the y value. And it looks like we have a pattern. We do indeed have a pattern. And I can go backwards here. So on any exam, for me, people have to fill out the entire graph. So they would be making sure that they didn't, get that back here. So they'd have to make sure that they did go through all the way to the end there, like I did here. All right, or close enough, like this one here. Should I not? No, let's not worry about that one. Okay, now this next one has a +2. And that should mean, because it's with it, it should mean that everything moves to the side. It's going to be, if it's +2, it looks like it would be going positives, but it's not. It's going to go to the left 2 units. Everything is. Now let's do that by XY table. XY. And I will do, no reason not to just do the same things here. I'm going to do 0, 0, 0.4, 5, 0.5, 0.8, 1, 1.4, 1.5, and 2. So if I put a 0 in here, 0 plus 2 is 2. If I put a 0.5 in here, I get 2.5, but the 0.5 part's not included. We just revert back to the integer. I get a 2.8 for the next one, but it reverts back to 2. If I put now a 1 in here, I get 1 plus 2 to get a 3. If I put 1.4 in there, I'll get 3.4, and we won't include the 0.4. 3.5, I also won't include it. But when I put 2 there, 2 plus 2, I'm going to get 4. So now for 0 and 2, let's go up here. And like the last problem, everything up to 1 is on the same line with it. Then everything greater than 1 and less than 2 reverts back to 1. And then it looks like we have a pattern again. And so I'm going to go backwards as well. There. Now, it actually looks as if this one here had been down here and then moved up. That's what it looks like, but it's actually not that. Instead of that, what it is that the one that's here used to be over here. And every point there moved over 2. So this filled in dot moved 2, the open circle is 2, and every point along here would have moved backwards 2, or towards the left side 2. So that's what really happened with that transformation. If it was supposed to be going up, it would be step value x. Okay, and then we would do the, let's see, it went up by 2, so plus 2 on the outside of it. So what that means is that plus 2 on the inside or outside will affect it the same way. Okay. So that's a step function here. Here's another one where now instead of adding and subtracting, we're going to have a multiplier, and a multiplier is only 0.5 or a half. Well, let's do this same thing. 0, 0.5, 0.8, 1, 1.4, 1.5, and 2. So if I put a 0 in here, 0 times 1/2 is 0. 1/2 times 0.5 is 0.25, but it still reverts back to 0. Half of 0.8 is 0.4, but it reverts back then to 0. 1, if I put a 1 in here, well, 1 times 1/2 is still just 1/2 for 0.5, and we revert back to 0. If I put 1.4 in there, I get 1/2 times 1.4, which would be 0.7. Still believe below 1. Same thing with 1.5 now. I would get, well, let's see what would happen. That would be, for half of that, as 7.5, 0.75, but still reverts back to a 0 because that's the closest or the first integer for the number. Now let's put a 2 in there. 1/2, 2. 2 times 1/2 is 1. So if I use a 2 for the x value, the result is that I get a 1. So now let's graph this over here. 0, and then even past 1, all of these points now. But the ending one, if I go to 2, I can't actually fill that in 1. For 2, I have to go up to where it's 1, and then I would complete the process. And then over here, I would be getting a higher number, and it would basically start going, whoops, yeah. Okay. And then that means we can go the other way here. There. So in this case, it's like these others, but the steps have been elongated. Oh, I just realized I made an error on one. I went down 1 too far. So let's fix that before we go further. Nope, not there. It's right underneath it, and then it's 2 of them. That's where graphing these sometimes with a few more numbers helps because it just has to include it in the graph. Okay, and it does. So, all right. So here the steps are longer or wider, I should say. So 1/2 does the opposite of what you think. You would think that it would make the thing smaller. Well, it doesn't, because what it does here is it doubles the amount of numbers that are between, say, 0 and 1 and 1 and 2. So those are step functions. They look like steps, but they're called really greatest integer functions because you revert back to the greatest integer before this number unless it's an integer itself.